So we are on to the last topic of the course, which is analysis of variance. Let's start with what is analysis of variance? The essential question in ANOVA is whether the variance between groups is greater than one would expect by chance, given the variance within groups. If your question is, are the means of these groups equal, and you have more than two groups, use ANOVA. You could also use it with just two groups, but a t-test would be easier. Also, if your question is, are the means of these groups equal, and you've split the groups by more than one factor, for example, gender, male or female, and receiving tutoring or not, use ANOVA again. Now, as I said, I'll say it again before I'm done. The essential question in ANOVA is whether the variance between groups is greater than one would expect by chance, given the variance within groups. And I keep saying this, and I really know that you have an intuitive understanding of this, even if you've never thought about it before in those terms. Maybe you've never lived somewhere that you have to haul your own garbage to the dump, but I have. And just take my word for it, that's pretty disgusting. And flies can be really irritating. So let's say I come up with some new electronic device that is supposed to repel flies. I put one device next to the piles of garbage at one dump and not at another. And then I have a crop duster spray pesticide over both so all the flies die and I can count them. Actually, I wouldn't do it. This is why I have interns to count them, but I digress. If I told you that the treated dump had two fewer flies than the untreated one, I don't think you would be too impressed. But if I said that there's a new premarital counseling program and it showed that the people went through it had on the average one fewer divorces than the people who did not, you would take notice. Now, why is that? Because in one place there's two fewer flies, and in another example, there's only one fewer divorces. And why is it? Because the variance in the number of divorces is far less than the variance in the number of flies in a garbage dump. So if there's a lot of variance in something within the groups, right? Like within the number of flies in a garbage dump, you might expect that there'd be a good amount of variance between groups, like say two different dumps. But if there's not a lot of variance within groups, then you wouldn't expect a lot of variance between groups. So let me repeat this. The essential question in ANOVA is whether the variance between groups is greater than one would expect by chance, given the variance within groups. The null hypothesis we're testing here is that all of the group means are equal, or stated another way, there's no difference between the mean of group one and group two, etc. One way ANOVA, you have one independent variable. Let's say I'm predicting high school GPA from participation in extracurricular activities, and I have four groups: no participation, cultural activities, athletics, and other. In a two-way ANOVA, you have two factors, say participation in extracurricular activities and gender. So you're looking at, do boys who participate in athletics maybe have a higher GPA than boys who don't? Girls who participate in athletics have a higher GPA than girls who don't. And you could also look at if the GPA difference is higher for boys than girls from athletics. Anyway, you'd have two factors. And I'm sure you can guess what a three-way ANOVA is. So how do you know if the means are significantly different? Well, you compare the F value obtained to the critical F value. So just like in t-test, we got a t value and compared that to the critical t. You get an F value and then compare that to the critical F value. How? Well, see the next video. But unlike calculating regression coefficients, which we talked about in the discussion forum, and require a significant amount of matrix algebra, computing the F ratio is relatively simple, relatively being the key word there.